Looking at this sort of question here, this is starting to look at more of the applications of mathematics and how we're going to use it beyond just a classroom where you've got 100 questions that say solve these equations. Now the key skills focused on in this one are quadratics. This can be found by looking at this part here and having a t squared. So highest power is a squared. That tends to lead towards quadratic work. Now there's two big parts of this question. We're given this scenario here with the equation of the height. The first one is calculating the height of the ball above the cliff top after 2 seconds. What the question then does is represents the journey of the ball as a graph telling us where we hit the bottom, and we have to then figure out a solution to that based on the information given. So let's work this question, break it down into both parts. So for part A, we want to know the height of the ball after 2 seconds. Well, after 2 seconds, looking at the equation, we know that t is equal to 2. T is our time variable, we know that that's equal to 2. And in order to figure out where the ball is at 2 seconds, we substitute t equal to 2 into the equation for the ball, which is given there. So we then know that the height is equal to 12 times 2, take away 5 times 2 squared. So the height of our ball is 12 times 2, which is 24. Take away 5 times 2 squared. 2 squared is 4. 5 fours are 20. So it's 20 take away 4, which is equal to 4. And this is the key thing. We have to make sure we include the units. It's height h meters of the ball relative to the cliff top. So the height is 4 meters. So we know at that point the ball is 4 meters above the cliff top. The second part of the question states after how many seconds will the ball hit the sea if the sea is 17 meters below the cliff top. So this is the cliff top here where we start. The ball is landed down here at 17 seconds. We want to know after how many seconds, i.e. how far along this way, will it land. So what we know is at that point the height is 17 meters. So for part B, the key bit of information we know is that h is equal to negative 17. What we can do is substitute that into our equation and see what we can get from there. So substitute it in and we end up getting negative 17 is equal to 12t take away 5t squared. Now what this looks like is the format of a quadratic. Now remember, to solve a quadratic, what we have to do is get everything to the left in the format of at squared plus bt plus c equal to 0, and then take it from there and solve it. So if I was to do that with this one and shift all of this across to the left, I'd end up with 5t squared minus 12t minus 17 equals 0. Now there's two ways to solve a quadratic at this point when it equals 0. We can either use the quadratic formula, or we can factorize. Now given that this is a non-calculator paper, we should be able to factorize this relatively easily. And in this case, when we factorize it, what we end up with is 5t minus 17, t plus 1. And that equals 0. So I get two solutions from this. What I end up with is 5t minus 17 equals 0, and t plus 1 equals 0. So I get t equals 17 over 5, and t equals negative 1. Now looking at the graph, there's one point where it happens. So we need to figure out which of the two of those solutions we choose. However, think of the context of the question. T is referring to time. One of my solutions is t equals negative 1. You cannot have a negative 1 time. You can't have negative 1 seconds. So what that means is I can disregard that solution there. And I can focus on the fact that I know that that is my solution. So what I can then say is therefore height is equal to negative 17 when t equals 17 over 5 seconds. I've solved the problem and I've put it back into the context. That's a key thing, as we've mentioned before, about questions like these. We're taking the maths, we're applying it, but we're applying it to a context. So when it comes to the final answer and communicating it, you have to make sure you communicate it logically and back in the context. Think of things that we should know. So i.e. in this case, t equals -1 couldn't be a solution because we cannot have a negative time. We have to make sure the contextual side of the questions matches up and that we use logic to finalise our answers.